Okay. Again, we're going to look at the solutions to the last three because there's a lot of movement, a lot of little pieces, and if you feel like you're just moving numbers around, you are, because you're simplifying, right? You're trying to get the square roots as small as possible, so you really are just moving things around using rules for fractional exponents and roots. Let's look at this one. Okay, if I have two roots, I can multiply the radicands together, so I can get 6 times 3 is 18t squared. 18t squared. Okay? Now, you're saying, well, you just put them together and now you're going to break them apart. It's true, because I'm going to break them apart, so it's 18 and t squared. And if they're roots, I do not need the multiplication sign in the middle. I can put it, but I do not need it. Right? 18 is not a perfect root, but 9 is, so 9 root 2. Right? T squared, the square root of t squared is perfect. It's t. And here's what I'm talking about. Now, is that t in or out? It's outside the square root. Right? Square root of 9 is 3. I have a t, and I have a square root 2. Right? And there's where you end up. Remember, we put the square root part at the end, and that's where you end up. Right? Let's look at the second one here. Just making sure I wrote it down correctly. Again, we're going to put it together. 2 times 8 is 16. A cubed times a squared is a to the 5th. And b times b to the 5th is b to the 6th. So now I have the square root of all of that. Right? One way to do it is how they did it on the slide, and that's the way I like, is to break them all into the pieces. So I have the square root of 16, the square root of a to the 5th, and the square root of b to the 6th, right? And we see there are some perfect squares there. The square root of 16 is 4. This one's not, but I can do the square root of a to the 4 and the square root of a, right? That's that little trick we looked at last slide. And b to the 6, because it's an even number, it is a nice b cubed, right? And then when we put it together, I have the 4. Now the square root of a to the 4th, I get a squared. I'm going to move the b cubed here because it's not in a root, and I'm going to put my root at the end. So again, I'll give you a second to look at that. But I have 4a squared b cubed and then the square root of a. Okay? If you want to look at it any longer, hit pause right now because I'm going to rub it out and I'm going to do part C. Got that erased. Let's go to part C here. 20x to the 5th over 5x. So we have 20x to the 5th over 5x, right? And they're in square roots, right? So the same way I multiplied, right, I could think of it this way. I could think of it as one big square root if I wanted to, right? Instead of 2, and that works with multiplication and division. Does not work with addition and subtraction, but does work with multiplication and division, where you can make this one square root. Right? And then 20 divided by 5 is 4, and x to the 5th divided by x, using our exponent laws, is x to the 4th, okay? And that's in the square root. And then, so I have the square root of 4, when I break it up, and the square root of x to the 4th, and that works out really nicely to be 2x squared. Okay? And that's how they came up with the 3 different answers that they came up with. See you next slide.